work with. But what I'm going to do is, first I'm quickly going to go over this particular one. Some of you might have the worksheet, some of you might have seen this before. For others, don't worry, because what the part I want to cover will be enough just to see from the projector. But before we start, I must say, you are the brilliant ones who are here to gather those last minute tips. We are not here for enjoying physics. We are here only in order to improve our performance, what way we can polish our paper. Okay, those are the tips I'm going to give you today with the broken pendulum example. But first thing, when you get into the investigation situation, the first thing you will look at is the worksheet that will be given to you. Okay, now suppose it's this one. Okay, aim of the experiment. Now in the aim part, there are two words that are highlighted. Okay, those two words you can spot. Yes, what are those two words that are highlighted in the aim?
Period and centripetal force.
Period and centripetal force. Okay. Now one of them is the independent variable, the other one is dependent variable. And soon we will decide which one is independent and which one is independent, which one is dependent. Okay. Now what they say is relationship between period of the mass in conical pendulum and its centripetal force found from each length. Any guess you want to give? Those of you who haven't seen this activity before, which one do you think out of these two is going to be dependent, that you will measure in class? Yes? Pardon? Period is going to be dependent variable, and centripetal force is going to be your independent variable. So try to, first thing in your worksheet that is given to you, try to spot the two variables. Okay, so get at least the first two ticks right for achieve. Next, there is one equation given, theta sine inverse R over L and FC mg tan theta. You are not going to come across 5 different equations in your actual assessment. This is a bit complicated one, that's why I'm going to not spend too much time on this. But quickly, if we can pick up things from here. This is the background information. Not going to spend much time on that. Now comes the physics theory here. She also finds the equation 1 over t square over 1 over 4 pi square mr fc. Second equation is there, and then there is a third equation. And we have already decided period is dependent variable and centripetal force is independent variable. So the first graph that you do, what should go on x-axis on the first graph? Pardon, centripetal force on x-axis, Fc. And on here, period. If you do other way round, there's actually nothing wrong, but you will not reach this grade. Okay, fantastic report, everything done brilliantly, but you will not get merit. Okay, so please remember, independent here, dependent there. Okay, what kind of relationship, okay, out of those 3 equations, which equation you think is the best to pick? And because you will be doing some kind of a comparison, so out of those 3 equations, which one you think is best to pick in order to decide the relationship between period and FC? First one, middle one, or the last one?
Middle one.
Middle one. Jimmy, can you tell me why middle one?
Because middle one is the most straightforward.
Worst is wrong with the other one? They look very straightforward to me as well.
Because the middle one is like straight like period to the centripetal force.
Okay, now when you draw a line graph, this is your y, this is your x, this is your line. Okay, the quantity on y, I want it to be period. Okay, because the equation is y equals mx plus c, and our equation is also going to be something like t equals some constant, which is the gradient fc. I don't know where the fc is going to go yet. Okay, that's how somehow it is going to be related. Okay, so which equation makes t as y? Clearly, is the middle equation. So focus on the middle equation, and somebody fresh, not the same people answering, can you tell me what kind of relationship period has with centripetal force in this equation? What kind of relationship period has with Fc? Yes, Francis, it's closer to your name, Fc. What kind of relationship? Square root. So period is square root relationship with Fc. Everyone agree with that? The period is square root relationship with Fc. If we write that, in my conclusion, I have found the relationship between period and Fc is square root relationship. Does that make Marker happy? No, why not?
It's an inverse square root.
It's an inverse square root relationship. If you look at it, this is how it is. Square root Fc. And when we write that in words, when we describe that in sentence, period is inversely proportional to square root of centripetal force, or Fc. That's a relationship. Okay, so our first graph will kind of give this shape. Okay, what do you think we should do in order to get this graph as a straight line graph? Which data we need to transform, and how do we need to transform that data? We want a straight line from this curve. Okay, and whenever we change a curve to a straight line, we do some change to one of the quantity. Which one are we going to change? And let's remember, we are going to change independent variable most of the time. You can change dependable, there's nothing wrong with that, but it is convenient later on for theoretical comparison to change your independent variable. Now when we change independent variable, okay, what should we do to Fc to get a straight line graph? Come on, look here, make it interactive. Yes,
Make it so it's 1 over
1 over
the
square root of Fc. Yes. So if we change this to time period 1 over Fc square root, then the graph should be a straight line either through origin. If you don't get your base fit line through origin, there is nothing wrong. That's also okay. Okay, because of some experimental error, you are getting an intercept. But please, most of your points are kind of here, and you think that's going to give me an intercept. Why don't I draw a line there and get a straight line? That will be marked as wrong, not achieved straight away. Don't force your line to go through origin. Draw the line of base fit. Even if it doesn't go through origin, that's okay. If you get a line of base fit and the relationship says no intercept, through origin, brilliant. Okay, but in reality, in experimental situation, it becomes really tricky. Draw the line of best fit. I'm not going to get into error line in this one. We will spend with the broken pendulum on error line. But do draw the triangle. You will say, that's a simple thing. I know how to do the gradient. Is it necessary to draw the triangle? Yes. For M, it is necessary to have that triangle. So if you have an error line there as well, like suppose this is my error line, draw the triangle for that one. Make it obvious to the marker which point have you picked up in order to calculate the gradient. Okay, so make sure you draw the triangle in both the cases, work out the gradient. Whatever is the answer for gradient, let us suppose our gradient is 5. Okay. What will be the unit for the gradient? I have not written these units for a reason. Can somebody tell me what unit do we use for time period? There's one place here, and there's one place there. Okay, what should be the unit for time period? Seconds. Unit for FC, Newton, but it is 1 over square root FC. So what is the unit? 1 over square root of Newton. Okay, so exactly what do you do with the quantity? Same thing happens to the unit as well. Okay, now I want to write the unit for the gradient. How do I calculate the gradient? Gradient is rise over run. Agree? Maths knowledge. So this rise over run is coming from, rise is whatever change is happening to the time period. Time is changing from this point to that point. So that much is the rise. So change in time period divided by change in 1 over FC. Change in 1 over FC, that's what the run is. Okay. So, what is the unit for time period? Unit seconds. Unit for FC is 1 divided by square root Newton. Okay, let's first solve this one because this looks quite complicated as a unit. S 1 over square root n is n minus half. Do you agree with this? 1 over square root n can also be written as n minus half. Do you agree with this? Because square root means n is at the power of half. Okay, and this half when you take up, it becomes negative half. Okay, and simplified form, the unit becomes S n to the power of half. That's what the unit is. Now either of this, you write this correct, you write this mark correct, you write this mark correct. If you don't want to simplify, fine, leave it there. But that's how the unit for gradients are written. You have done perfect graph, you've done perfect calculation for gradient, you have worked out error line, gradient, everything, but you cannot write your units again. This is not coming in your plate. Okay, so unit is important. And I'm going to give you, end of this session, a summary of what is required for each part in the report in order to reach merit, excellence and whatnot. Okay. Now last thing before we move into the broken pendulum. Now if this is the error line, let's assume. Any guess for the gradient of this error line? Any guess? Give me any number that you think will be the gradient. Yes. Yeah. I'm sorry, I don't know your name. Don't look behind. Yeah. Yeah.
Like the
Like-
actual error that you get minus the gradients, kind of. I don't know.
Yeah, you're telling me about uncertainty in the gradient. I want a number for red line's gradient. Give me any number that you think could be the gradient of
4.8.
4.8. Okay, 4.8. Any guess? Any other guess? This is first choice. Second choice. Any other choice for gradient? Give me a number and I'll tell you whether that guess could be right or wrong.
8.
Pardon?
8.
8. Okay, 8. Third, last chance. Any guess? Any number? 1. Okay. The correct answer could be, I'm not saying that's the perfect answer, that's what the exact answer is, but the only correct answer possible is 8. Because as you can see, obviously this red line is steeper than the black line. So if it is more steeper, it is going to have a bigger gradient. This is the maximum error line, which is going from the bottom vertical bar to this might have been the vertical bar here, the top vertical bar. That's the maximum error line. But if your line was this, from this to this end, then it was a minimum error line. The gradient would be less than 5. Remember that. Whichever error line you are going to draw, make sure your error line is actually crossing the best fit line, starting from one end going to the other side. Whether it is this or that, if you think your error line, like I have seen in one book today, was kind of, because the number was here, this was the bar and it was kind of going this way. Ignore that line, don't draw it. Try to draw on the other side if it crosses. So the line that is going to cross, use that as error line. Okay, so let's suppose this one, the gradient was 5.42 and the error line gradient which we had initially, the red, this one, okay, the gradient was 5.98. Okay, you won't have such a big difference. It's going to be a smaller difference. That's why I've tried to bring the numbers closer. 5.48 and 5.98. What do we have to calculate from here now? Uncertainty in the gradient. So how do we calculate the uncertainty in the gradient? This is a gradient of best fit line. I'm just using the short form. Okay, and this is M dash, gradient of error line. Okay, so uncertainty in the gradient is going to be M dash, bigger one minus M. If it's a maximum error line, M dash minus M. If it's a minimum error line, then it is going to be M minus M dash. Okay, where gradient M dash is the gradient of minimum error line. So let's work out the gradient here. Uncertainty in the gradient, 5.98 minus 5.42. Quick calculation, can somebody tell me the answer? 0.4. 56.
No,
56, sorry. So the final gradient is plus and minus uncertainty is 5.42 plus and minus 5.6. This is yet should not be my final answer if I am aiming for excellence or merit. What do we need to do to this gradient now? Round it.
To one significant.
One significant figure. What should be one significant figure? Uncertainty. So first look at the uncertainty, round it to one significant figure, it becomes 0.6. Okay, now this helps me to decide what should I do to this number. This number is not going to have same significant figure as uncertainty, but will have same number of decimal places as this number. So this becomes 5.4 plus and minus 0.6 is n minus half. That's my final answer needed for gradient. Not finished yet, and now we are going to write down the mathematical equation. And mathematical equation is going to be, because it's coming from this graph, we know that time period is directly proportional to 1 over square root fc. Time period is constant divided by square root fc. And what is this constant? Gradient. And this is all coming from this equation mx plus c, where c is the y-intercept, x is x value, and m is the gradient. So, how do we write this? T equals 5.4 plus and minus 0.6. Make a bracket around it, because the next x value is 1 over fc. So, 1 over square root fc is multiplied with the whole number, not just with the last one. That's why please put the bracket. Plus, this does have an intercept c. So whatever that c intercept is going to be, let's assume if this was 0.5, 1, 1.5 and so on, and this red line is actually going through origin. So what you have, the c value is 0.5 plus and minus, is it 1 I think, 1 plus and minus 0. Or just leave it like this, 1 plus and minus 0. That's your c intercept. But if this c intercept was somewhere here, like 0.5, then you will write that value.
Wait,
Yes?
so do we have to write the intercept?
Intercept as well.
Oh, okay.
Excellence. Yes. Yeah, excellence will look for those little things. Yeah. Any other question before we move on to broken pendulum? Yes? What if your uncertainty is negative? Good question. Let's do it. This was, suppose, your base fit line and your error line is this. Numbers, let's suppose here is 0.5, 1, 1.5. So you go on to this side, and what you have here is negative 0.5, negative 1, and negative 1.5. So this line is touching somewhere here, maybe at 1.4. So how do we write the equation for that one? Is t is 5.4 plus and minus 0.6 if 1 over square root fc plus, and then the c intercept is going to be 0.5 plus and minus. You will not write 1.4. Okay, yes, the value here is 1.4, but remember there is this part as well. So uncertainty is not just this, it's the whole thing. That means your base fit line is somewhere between this end 1.4 and this end 1.4. Other error line should have been something there. So base fit line is somewhere in that area. That's what you're uncertain about. Okay, so you will write plus and minus 1.9, which is a very big uncertainty. Normally it doesn't come that big a number. You won't write negative, but you will write plus and minus 1.9. Get it? If it comes as a negative intercept, you will count the difference and you will write it there. And moreover, these other things, these little minor things are more needed for M and excellence. Yes.
Why is it 70?
Why is
For that one.
it was touching here?
Yeah, but then it's
But I have written that 0.5 initially. Was it, yeah, 1, the black line is touching at 1, sorry, the blue one, and uncertainty 1 plus and minus 0.
but the difference between the uncertainty and the errors.
Oh, good question. Good. This 1, sorry, yes, 1 plus and minus 1. Good spotting. Yes. Any other thing before we move on? Yes.
Do we have to do 2 airlines?
No. 1 error line is enough as long as that's good enough. 1 error line.
Okay.
Yeah, do you have any question to ask? Were you being told to do 2 error lines?
No.
Yeah.
This one, but then should we do 2 to work like?
If you get 1 very clear enough, you don't even need to bother for the second one.
Okay.
But in case if your first one is not able to cross it, then try to look for the second one, whether that is crossing it.
And
Okay.
that would be
In case if that's not working, in that case you might have to ignore either the first number or the last number as an outlier and see whether it works with the second last number. If still it is not working, in that case it's going to be a little bit challenging. You will go for horizontal error bars. That's the only time. If you're not getting error line either way, then you go for horizontal error bars and draw the line of best fit. And I'll tell you, this becomes a very, very rare chance.
Oh, yeah, so you can't.
In last years, about 120 students, it was only 1 student who had to do horizontal error bars. So it's not that you will come across anything. And the experiment that you're getting, we both have tried that experiment. We are very comfortably getting vertical error bars. Yeah. Yeah. I will explain you. Yeah, later. Okay, let's move on to broken pendulum. Okay, the experiment is set up here. Shh. One sec, you will get time to discuss whatever you want to. The experiment is set up here. You are not doing experiment, but please feel free to spend as much time as you want to get a hang of this experiment, how exactly it works. What kind of difficulties I might come across while doing this experiment. What I think is a control variable. What's the best control variable in this one? Think about those things while you come and spend some time with the gear. And then look into this part. First read this please. Then come and spend time here. Look at the theory equation given. This table, I would suggest transfer this table to your book so that you can add extra columns to it. And yeah, we will spend time, rest of the time, writing full report as if this is your final assessment. And the report, if you want your target is achieved and you think once you have reached that, you're more than welcome to leave. Even otherwise, you're more than welcome to leave at any time when you want to. But you can stay until you don't feel that I think I have reached excellence in this report. How does that sound? Yes? Thank you. So now start working.